Good morning to everybody. Let us discuss on aerial photography and satellite images. First of all, let us discuss on aerial photography. Aerial photography means photography from the air using aircraft or helicopters. Photography is production of permanent images by means of the action of visible light on sensitized surfaces. They are film or array inside a camera, which finally giving rise to a new form of visual art. Aerial photography is one of the most common, flexible and economical forms of remote sensing. Aerial photography was the first method of remote sensing and even used today in the era of satellites and electronic scanners. Aerial photographs will still remain the most widely used type of remote sensing data. Aerial photographs were taken from balloons and kites as early as the mid 1800s. Gasper Felix Tournachon Nadher took the first aerial photograph from a captive balloon from an altitude of 1200 feet over Paris. Aerial photographs provide a bird's eye view of large areas, enabling us to see surface features in their spatial context. They enable the detection of small scale features and spatial relationships that would not be found on the ground. They are virtually permanent records of the existing conditions on the earth's surface at one point of time and used as an historical document. They provide a synoptic or bird's eye view of the terrain conditions and are useful in studying dynamic phenomena such as flooding, moving, wildlife, traffic, oil spills, forest fires, shoreline change detection, and also helps in agricultural resources mapping, forest mapping and urban sprawl mapping. And when we come to the three-dimensional perspectives, aerial photographs provide a stereoscopic view of the earth's surface and make it possible to take a measurements horizontally and vertically, which is a characteristic that is lacking in most of the remotely sensed data products. Aerial photographs can be made with any type of camera, example 35 mm small amateur or 70 mm or special cameras that are normally used. There is a strip type, panoramic, panchromatic and multispectral photographs. Normal, wide and super wide angle cameras are normally used in aerial photography. Many successful applications have employed aerial photography made from light aircraft with handheld 35 mm cameras. For the aerial study of large areas, high geometric and radiometric accuracy are required, and these can only be obtained from using special cameras that are built for the purpose. Aerial mapping cameras, which are also called as metric or cartographic cameras, are single lens frame cameras designed to provide extremely high geometric image quality. They employ a low distortion lens system held in a fixed position relative to the plane of the film. The film format size is commonly a square of 23 centimeter or 230 millimeter on a side. The total width of the film used is 240 millimeter and the film magazine capacity ranges up to film lengths of 120 meters. A frame of imagery is acquired with each opening of the camera shutter, which is tripped at a set frequency by an electronic device called intervalometer. They are exclusively used in obtaining aerial photos for remote sensing in general and photogrammetric mapping purposes in particular. Single lens frame cameras are the most common cameras in use. So, let us discuss on types of aerial photographs. When we say types of aerial photographs, see, depending upon the orientation of the optic axis of the camera, There are two types of aerial photographs. The angle at which the photograph is taken is used to classify the photograph into one of three types. They are vertical, high oblique and low oblique aerial photographs. Now, let us discuss what is vertical aerial photographs. Vertical photograph taken with a single lens and which is the most common type of aerial photography used in remote sensing applications. The vertical photography is taken with the camera optic axis point vertically downwards. Vertical photographs are taken straight down. They are mainly used in photogrammetric and image interpretation. In India, Survey of India generates the topographical maps based on photogrammetric techniques and vertical aerial photographs are used for this purpose. Pictures that will be used in photogrammetry are traditionally taken with special large format cameras with calibrated and documented geometric properties. Vertical photograph taken with a single lens is the most common type of aerial photography used in remote sensing applications. A truly vertical aerial photograph is rarely obtainable because of unavoidable angular rotation or tilts caused by the angular attitude of the aircraft at the instant of exposure, and they are called truly. These unavoidable tilts cause slight, they are 1 to 3 degrees unintentional inclination of the camera optical axis, resulting in the acquisition of tilted photographs. So, vertical photographs have properties similar to those of a map with an approximately constant scale over the whole photograph and therefore, can be used for mapping and measurements purposes. Now, let us discuss on oblique aerial photographs. Oblique photography is taken with the camera axis pointing obliquely downwards, that is intentional inclination of the camera axis. Oblique aerial photographs are again classified into high oblique and low oblique aerial photographs. In high oblique aerial photographs, the tilt of the camera is sufficient so that one can see the horizon. In low oblique aerial photography, one cannot see the horizon because the tilt is less. The most important geometric properties of an aerial photograph are those of an angle and scale. To understand the geometry of aerial photographs, one must make use of the oblique aerial photographs. In case of oblique aerial photographs, the principal point, the nadir point and the isocenter are separated out, whereas in vertical aerial photographs all the three are intersecting at a common point. Now, normally in aerial photographs there are some index marks marked at the center of the edges or at 4 corners of the photographs. By joining the opposite fiducial marks, one can mark the principal point of the on scale of aerial photographs, that is photographic scale. The scale of a photograph expresses the mathematical relationship between a distance measured on the photo and the corresponding distance measured on the ground. A photograph scale is an expression that states one unit of distance on a photograph represents a specific number of units of actual ground distance. Scales may be expressed as unit equivalents, that is 1 millimeter is equals to 25 meter, representative fractions, that is 1 over 25,000 or ratios 1 is to 25,000. Unlike maps which have a constant scale throughout, the aerial photographs have a range of scales that vary in proportion to the elevation of the terrain involved. The most straightforward method for determining photo scale is to measure the corresponding photo and ground distances between any 2 points. The scale is then computed as the ratio of the photo distance to the ground distance. that is scale of the photography means it is photo distance divided by ground distance, that is d by dsd. For instance, if the photo scale were 1:50,000, then 1 centimeter on the photo would represent 50,000 centimeters, that is the first number that is representing the map distance is always 1. The second number that represents the ground distance is different for each scale. The larger the second number is, the smaller the scale of the map, that is large is small. Now, let us discuss the scale in vertical photographs. The photo scale is given by the simple definition image distance divided by ground distance. In the case of a truly vertical photograph of a flat terrain, it can be shown by a simple geometry that the scale is equal to focal length divided by flying height, that is capital S is equal to focal length divided by capital H. From this relation, it is evident that in a vertical photograph the scale varies with the relief variations on the ground, where f being constant. Quite often the terms large scale and small scale are confusing to those who are not working with scale expressions on a routine basis. A convenient way to make scale comparisons is to remember that the same objects are smaller on a smaller scale photograph than on a larger scale photo. A large scale photograph will provide a detailed and high resolution view of a small area. Large scale versus small scale can be used as a measure of viewable detail. Small scale implies less detail is visible, large scale implies more detail is visible. Thus, as scale increases, becomes larger and more zoomed in, more detail can be displayed without overcrowding the screen display. Now, let us discuss the scale determines, how to determine the scale. A map scale determines how a feature will be represented. On a large scale map, a river might be represented as a polygon rather than a line, or a city's extent is so large that it can only be accurately represented as a polygon rather than a point. Small scale maps cover larger area and provide less detail. Large scale maps cover smaller area, but they provide more information. For example, 1:50,000 scale map provides the contour information with the 20 meter interval, and 1:25,000 scale map provides information with 10 meter contour interval. Aerial photography is defined as the science of making photographs from the air for studying the surface of the earth. The main uses of the aerial photographs are for pictorial representation, that is nothing but the mosaic making, then preparation of base maps, photo interpretation and photogrammetric surveys. The immense wealth of information recorded on the aerial photographs is being made use of more and more in economizing and expediting natural resources surveys in the field of geology, soils, land use, engineering and town planning. In order to be useful for the preparation of base maps and for representation in natural resources surveys, the aerial photography should fulfill the following requirements. Let us discuss what are they. The photography should provide faithful image of even the smallest detail perceptible from the camera station. The definition of the image should be sharp, bright and clear. The photography should be distortion free. It should be continuous with sufficient overlapping of successive photographs. Scale variation should be within the tolerable limits. Tilt and crop should be within the tolerable limits. Mounted cameras may be triggered remotely or automatically. Handheld photographs may be taken by a photographer. Now, let us discuss the subject of photogrammetry. What is photogrammetry? The photogrammetry mainly deals with the geometrical aspects of aerial photographs and includes the science of obtaining reliable measurements by means of quantitative study of the aerial photographs. Photogrammetry is composed of three Greek words. They are photos meaning light, gramma meaning something drawn or written, and metron meaning to measure. In the literal sense, photogrammetry is the art of scribing and measuring by light. In a broader sense, it is the method of determining the shape, sizes and positions of objects using their imaged positions. Thus, it includes photographing an object, then measuring the image of the object on the processed photographs and reducing the measurements to some useful form such as a topographical map or a numerical cadastre. The end product in the case of aerial photography is mainly a topographical map, which are normally used to generate the base maps. A pair of photographs taken from two camera stations covering some common area constitutes a stereo pair, which when viewed in a certain manner gives an impression as if a three-dimensional model of the common area is being seen. The stereoscopic vision is the capacity of the brain to perceive an object in three dimensions by physiologically fusing the two different views of the object by the right and the left eye. One of the advantage of all aerial photography is that when taken as overlapping pairs, and they are also called as stereo pairs, they can provide a 3D view of the terrain that are also called as perspective view. The 3D view is made possible by the effect of parallax. Parallax refers to the apparent change in relative positions of stationary objects caused by a change in viewing positions. Our left and right eyes are recording information from two slightly different viewpoints. The brain uses the effect of parallax to give us the perception of depth. An aerial mosaic is an array of overlapping aerial photographs which are systematically assembled to form a continuous pictorial representation of a terrain. Mosaics are useful for planning purposes. For photogeological studies, the mosaic provides an overview of the nature of the terrain, which helps in forming an impression in the interpreter's mind about the photographic texture. Adjacent but overlapping aerial photos are called stereo pairs and are needed to determine parallax and stereo or 3D viewing. Aerial photography in India is controlled and coordinated by the Survey of India, and the information about the existing photo coverage is available with the Surveyor General. The use of aerial photography rapidly matured during the war, especially during the Second World War, as reconnaissance aircrafts were outfitted with cameras to record enemy movements and defenses. At the start of the conflict, the usefulness of aerial photography was not fully appreciated, with the reconnaissance being accomplished with map sketching from the air. Now, let us discuss on orthophotos. What are orthophotos? Vertical photographs are often used to create orthophotos, alternatively known as orthophoto maps. Photographs which have been geometrically corrected so as to be usable as a map. In other words, an orthophoto is a simulation of a photograph taken from an infinite distance looking straight down to nadir. Perspective must obviously be removed, but variations in terrain should also be corrected for. Multiple geometric transformations are applied to the image depending on the perspective and terrain corrections required on a particular part of the image. Now, let us discuss on the satellite images. A satellite image is a photo or image representation of an object that was taken using a satellite. Generally, these are images of the earth's surface features and they are taken using artificial satellites. Satellite imaging uses wide variety of cameras, instruments and sensors that are installed in satellites orbiting the earth. The data provided by the spacecrafts are of great use to surf forecasters. They capture images of the land, sea and clouds which contribute to developing an overall assessment of global weather. The ocean, atmosphere and the land can be studied in a better way using these satellite images, which are available at the different resolutions, that are resolutions in the sense with the different spectral, spatial, temporal and radiometric resolution. Now, let us discuss on nature of remotely sensed image data. Data, as you know, consists of measurements. Here we consider the nature of the phenomenon that many thought, though not all, remote sensing systems measure electromagnetic energy. Many of the objects that make up the earth's surface reflect and emit electromagnetic energy in unique ways. The appeal of multispectral remote sensing is that objects that are indistinguishable at one energy wavelength or at one wavelength, particular wavelength, may be easy to tell apart at other wavelengths. That concept we are calling it as multispectral concept. Satellite images are one of the most powerful and important tools used by the analysts. They are essentially the eyes in the sky, the weather monitoring satellites, for example, Indian National Satellite, which provide images which can reassure forecasters to the behavior of the atmosphere as they give a clear, concise and accurate representation of how events are unfolding. Forecasting the weather and conducting research would be extremely difficult without satellites. Data taken at stations around the country is limited in its representations of atmospheric motion. It is still possible to get a good analysis from the data, but because the stations are separated by hundreds of miles, significant features can be missed. Satellite images aid in showing what cannot be measured or seen. In addition, the satellite images are viewed as truth. There is no chance for error. Satellite images provide data that can be interpreted first hand. Satellite images give a good representation of what is happening at every point in the world, especially over oceans where large gaps in data occur. Data can only be taken at certain points around the world. There are two types of satellites that orbit the earth. They are polar orbiting satellites. They are also called as sun synchronous satellites, and there is one more type of satellite that is called as geostationary satellites. Normally weather predictions and all are carried out using geostationary satellites, whereas earth's natural resources are mapped using polar orbiting satellites. Geostationary operational environmental satellites, they are normally called as ghost series of satellites. They remain above a fixed location on the earth's surface approximately 36,000 km above the equator. Because the satellites rotate with the earth, they always use the same portion of the globe, whereas the polar orbiting satellites in contrast orbit at much lower elevations. Their altitude is about 700 to 900 km and the path is normally larger. It is ranging from satellite to satellite, but in some of the satellites the path is 2400 km wide centered at the orbital path. The polar satellites observe a new path on each orbit. polar satellites are not as useful to operational meteorologists because they do not continuously view the same area, but they are very useful for natural resources mapping because even 1 meter object of the earth's surface can be detected by these satellites. Whereas geostationary satellites allow meteorologists to view the weather as it develops, since they view the same area continuously. There are many different types of satellite images. Of most use to meteorologists is the visible, infrared and water vapor images. All of these images can be taken with one satellite located out in space. The visible satellite images are equivalent to taking a picture with a normal camera. Light is required for images to be photographed. For this reason, these images are only useful when the sun is shining on the area to be photographed. The presence of clouds does not always imply precipitation. The circular clouds associated with low or a little lighter. From the visible satellite images, we can not tell if these slightly lighter clouds are producing rain, as all cloud types are treated equally. The infrared satellite images can help us in distinguishing rain clouds from other types, which make it a remarkable. Now, infrared satellite images. Infrared measures heat. Dark areas represent warmer temperatures, while white areas slightly colder temperatures. Meteorologists need to be careful in assuming all of these clouds are producing precipitation. Cirrus clouds often form at high altitudes and show up well in the infrared, but produce no precipitation. In addition to that, let us see what are the water vapor satellite images. The water vapor image is another valuable tool in satellite analysis. Water vapor images, as the name implies, shows regions of water vapor located in the upper troposphere. Generally, dark areas represent by dry air, while whiter areas show moist air. Dark regions can be associated with air that is being forced downward toward the earth's surface. These airs had all of its water condensed out and can then behave differently from moist air. The dry air usually represents fair weather and whiter. More moist air shows regions where this moisture can be possibly converted into clouds or precipitation. Putting all three types of satellite images together, it becomes apparent that the significance of the weather event. The visible images shows the 3D nature of the low pressure system and the developing storms. The infrared helps specially which cloud areas are likely causing the most notable weather. The water vapor indicates where the most moisture in the upper levels is located and the associated jet streams. In the image acquisition process, four concepts are fundamental. When we talk about the polar orbiting satellites, they are orbiting from lower altitude and they provide enormous information, and these type of satellites are very useful for natural resources mapping. Now, let us discuss what are these resolutions. They are the spatial, spectral, radiometric and temporal resolutions. The spatial resolution defines the detail level of an image. It means what is the minimum recognizable unit size within the captured data. The spectral resolution determines the sensor capability to define short intervals of wavelengths. What wavelengths of energy are being captured by the imaging devices. that is about the spectral resolution. Coming to the radiometric resolution, the radiometric resolution of an imaging system describes its ability to discriminate very slight differences in energy. It is also called as the quantization level and expressed in bits. The temporal resolution determines the necessary time for the sensor revisit a specific target and image the exact same area. So, in case of this is used to monitor the dynamic changes occurring on the earth surface. These huge volumes of the data sets need an efficient hardware and software infrastructure. However, still a limited capacity is available for extracting information from large remote sensing image databases, but the technology is advancing. Now, we have the supercomputers and we have sufficient manpower is available. Definitely, we can extract maximum information from the remotely sensed data, that is from the aerial photographs and from the satellite images. I hope you understood the concepts.